This is my demo teaching for grade 7 mathematics. Class, kindly stand up for the opening prayer. Good afternoon, class. First of all, my name is Jerbilyn Lu and I am now your teacher for this mathematics class. So before you take your seat, can you pick up a pieces of paper under your table? If not, then please you may now take your seat. Is there any absent for today? 9? Okay, so please maintain that perfect attendance. It seems that you are all alive today. But before we start our lesson, let us have a review of our meeting last class. So, who among you here still remember what's an integer? Okay, very good. How do you define an absolute value of a number? Okay, that's right. So, it feels great that you still remember our last topic. It seems that you have fully understood our last topic. Now we will proceed to the next one. But before that, let us play a game. Who wants to play a game? Okay, so I will group you into 2 groups. And each group will have a presenter who will act out the word based on the pictures given. And the rest of the group will guess the word that is given based on the picture. So the group who will guess the most will be the winner and will have 10 points each. Okay? Since all of you have good observation in the game, let us have an activity that is related to our next topic. Who is excited for this? So, okay, let us begin. I will group you into 4 groups. So, let us please start counting from 1 to 4 and go to your respective groups. What we are going to do is to solve a problem operations based on the flashcards that I will give to you. And these are the flashcards. It contains some problem solvings. And the first group who will finish the problem solving should shout or yell within the group. And I will choose at least one representative from each group that will present their work provided with some guided questions. You should present your work provided with these guide questions. What have you noticed in your activity? What do you think is our topic for today? And how do you derive with your answers? And how will you define an integer? Now, let us formally start our discussion. Today, we are going to learn what are the 4 operations on integers. So, the 4 operations on integers are addition, subtraction, multiplication, and division. But first, let us learn what is the addition on integers. Now, let us formally start our discussions. Today, we are going to learn about the operations with integers. So, namely, the 4 operations on integers is addition, subtraction, multiplication, and division. But first, let us start with addition. Now, let us first discuss the addition of integers. So, before performing the addition, we also have to follow some rules. So, these are the rules. If the numbers have same signs, then first, we must find the absolute value. Second, add the number obtained in step A, which is to find the absolute value, and C is to attach the common sign. So, these are some examples from the addition. So, can you see this? So, when addends have the same sign, meaning you have to add it. Use that sign when you write the sum. So, for example, 5 plus 8. So, 5 and 8 has the same sign, which is positive. So, you have to add this. So, 5 plus 8 is equal to 13. And it is positive because this common sign is positive. So, for the second example, negative 20 plus negative 30. First, you must find the absolute value. Find the absolute value of negative 20 and negative 30 is positive 20 and positive 30. So, you must add those. 20 plus 30 is equal to 50. But it says in the third rule that attach the common sign. And the common sign here is negative. So that's why the answer is negative 50. So for the second rule, these are for the unlike signs. Find the absolute value, subtract the smaller number, and use the sign of the bigger number. So for example, negative 6 plus 4 is equal to negative 2. So how did this happen? It says here that subtract the smaller number. So the smaller number in this example is 4. So negative 6 minus 4 is equal to 2. That is why it is 2, and it says that use the sign of the bigger number. It is negative. So that's why the answer is negative 2. Gets? So for the second example, 45 plus negative 10. The answer is positive 35. It is positive because 45 is bigger than 10 and his sign is positive. That is why the answer is positive 35. Now, it seems that you have already understand the addition. Let us now proceed to the subtraction of integers. Here, rule. Subtracting a number n from another number is the same as adding n to the other number. So, I have some examples here. It says, to subtract an integer, add its opposite. For example, 4 minus 12. So, the opposite of 12 is negative 12. So, it becomes 4 plus negative 12 is equal to negative 8. Because you will subtract this and you will also use the sign of the bigger number. So, it becomes negative 8. Second example, 9 minus negative 12. First, you have to get the opposite of negative 12, which is positive 12. So, it will become 9 plus 12 is equal to 21. Because negative times negative is equal to positive. You will also learn this in the multiplication of integers. So, for the second example, the opposite of negative 15 is 15. Here, 1 minus negative 15 is equal to 1 plus 15. It will become 1 plus 15 because negative times negative is positive here, and the opposite of negative 15 is 15. That is why it will become 1 plus 15, and the answer is 16. Copy the sign of the biggest number, and this one, negative 20 minus negative 15, negative times negative equals positive, so it will become negative 20 plus 15 is equal to negative 5 because you will copy the sign of the negative 20, which is the bigger number than the 15. How is learning subtraction and addition class? Is it okay? Do you enjoy it? So, since you understand well the subtraction of integers, let us now proceed to the third operation, which is the multiplication. You may have noticed that using repeated addition in finding the product of two integers is tedious. Fortunately, the process of multiplying integers can be simplified using the following. So, these are the rules for the multiplication. Rule 1. If the number has same signs, you have to find the product of the absolute value, and the product will always be positive. This is only applicable if the number has same signs. So, for the second rule, which is the unlike signs, find the product of absolute value and the product is always negative. So, same signs, negative signs, same sign, positive, unlike sign, negative. Okay, so for example, when the factors have the same sign, the product is positive. So, it says here that it is positive. So, example, 5 times 6 is equal to 30. It is positive because 5 and 6 are both positive. So, the product will surely be positive. So, here, negative 13 times negative 3 is equal to positive 39. It is positive because both the numbers 13 and 3 are negative. It says in this rule that the product is always negative if the number has both unlike signs. So, here, when the factors have different signs, the product is negative. Negative 6 times 8 is equal to negative 48. It is negative because 6 is negative and 8 is positive. They have unlike signs, so the product will always be negative. For the second example, positive 9 times negative 11 is equal to negative 99 because for the same reason, it is negative because the other number is positive, the other is negative. Now, let us proceed to the last operation, which is the division. Can I ask Miss Lian Kimberly to read the rule? Okay, thank you. So, rule 1. If the numbers have the same sign, then you have first to find the quotient of absolute value and the result is always positive. So, if the numbers have unlike signs, you have to find the quotient of their absolute value and the result is always negative. Have you noticed that multiplication and division applies the same rule. If the two numbers have the same sign, then the product or the quotient will always be positive. If the numbers have unlike signs, then the quotient or product will always be negative. So let us give an example. So it says here that when the dividend and divisor have the same sign and the quotient is positive. For example, 45 divided by 9 is equal to 5. It is positive 5 because 45 and 9 are both positive, so the quotient will always be positive. Second example, negative 20 divided by negative 6 is equal to 20. It is positive for the same reason because both the numbers are negative, so based on the rules, the quotient will always be positive. For this one, when the dividend and divisor have different signs, the quotient is negative. Here, 35 divided by negative 5 is equal to negative 7. It is negative because, as you can see, 5 is negative and it is the divisor for 35. 35 divided by negative 5 is negative 7. For other example, negative 250 divided by 10 is equal to negative 25 because both the numbers are not the same. The other one is negative and the other one is positive. That is why the answer is negative. After learning all the four operations of integers, let us now learn to appreciate the use of integers in real-life situations. So, I will show you a video clip about the use of integers in real-life situations. But we can also deny the fact that nowadays, most of the students hate mathematics. But why is that? Though mathematics is really part of our life, even if we take a bath, we eat, or even if we travel, it clearly shows that mathematics always has an integration in our lives. So, do I make myself clear? I hope you learn to appreciate mathematics more and learn to love it as well as I love mathematics.
Do you know that the optimal temperatures in the freezer of a refrigerator is around negative 18 degrees Celsius, and that in the other compartments is around 4 degrees Celsius? It is because different foodstuffs require different temperatures to keep them fresh for a long time. Note that a positive number such as positive 4 degrees Celsius can be written without the positive sign. Negative 18 degrees Celsius means it is 18 degrees colder than the freezing point of water. It is 18 degrees Celsius below 0 degrees Celsius. 4 degrees Celsius means it is 4 degrees warmer than the freezing point of water. It is 4 degrees Celsius above 0 degrees Celsius. Instead of using the terms going right or going left to give directions, we can use positive or negative numbers to indicate directions. For example, we can say, the Louvre Museum is 5 kilometers from the hotel, and the Eiffel Tower is negative 2 kilometers from the hotel in the opposite direction. Often you can find positive and negative numbers on shopping receipts. The positive number for cash means that the shop has received 20 ringgit from you, and the negative number for change simply means that the shop needs to pay out 1 ringgit and 50 sen back to you. Positive and negative numbers are used in many ways in our daily lives. If positive represents above a reference point, then negative represents below the same reference point. If positive represents a direction to the right, then negative represents a direction to the left. If positive represents money received, then negative represents money paid out. Conclusion: negative numbers represent the opposites. The group of all the negative whole numbers, positive whole numbers, and zero are called integers. Any decimal numbers or fractions are non-integers. Hence, integers do not include any decimal numbers or fractions.
As a future mathematics teacher, I really hope that you have enjoyed our lesson for today, class. Mathematics is a very enjoyable subject and I hope you'll learn to enjoy and appreciate it more. So, since you all have full knowledge about the operations of integers, please get your ball pen and one whole sheet of paper and answer the following. And for your assignment, you can answer the following. You! Yes, you! I hope you enjoy learning and thank you for watching!